Welcome to qnawire.
So in this problem, we have been given an hydrogen atom which is in an excited state, 5D states, and we are supposed to name all the states to which this atom is allowed to jump with an emission of photon. Now, since there is an emission of photon, which means that the hydrogen atom goes to the lower state. So when the hydrogen atom was in 5D state, the principal quantum number is 5. So to jump it to the lower state, the n can take values either 1, 2, 3, or 4. And the d here corresponds to the L subshell. And so d corresponds to the L subshell, which takes the value of 2. Okay. And if you look at the selection rules, the allowed transition are for the states for which the change in the orbital quantum number is either plus or minus 1. So in this case, the hydrogen atom can only jump to the states for which L values can take either 1 or L can be 3. So when you use delta L is equal to plus or minus 1, we find out that the states which are possible for the hydrogen atom to jump from photon emission are only L is equal to 1 or L is equal to 3. Okay, so we take it case by case. So for L is equal to 1, we say that this is a P subshell. I think this is from table 3. So you can find this information in table 3, and L is equal to 3 corresponds to F subshell. Okay, so for any given value of n, L can take values from 0 to n minus 1. So we basically find the possible destination states are, so since n can only take values 1, 2, 3, and 4, and L can take values 1 or 3, we find the possible states are either 2p, which corresponds to principal quantum number 2 and orbital quantum number 1, or we see that it can either go to 3p, principal quantum number 3 and orbital quantum number 1, or it can go to 4p, principal quantum number 4 and orbital quantum number 1, or it can go to 4f, principal quantum number 4 and orbital quantum number 3. It cannot go to 1s because in that case, so 1s is forbidden transition, because in that case the value of L will change. So basically delta L will be 2, and this is a forbidden transition according to the selection rules. Okay, now next we move on to part B, in which we are supposed to tell how many different wavelengths are there, ignoring the fine structure constant. So in an hydrogen atom, L does not affect the energy. So energy does not depend on L basically, which means that for energy purposes, we just have to consider the value of N, right? And as I have shown you in the previous example, the allowed transition are only for the values of N is equal to 2, 3, and 4. So which means that there are 3 different photon wavelengths possible. Three different photon wavelengths. Sorry. So basically there are 3 different photon wavelengths possible, corresponding to these three possible changes in the energies. Since we go from 5 to 4 or 5 to 3, so let me just write that we can go from 5 to 4 or 5 to 3 or 5 to 2. Okay,